Hello, it's Professor Elliott once again, and today we're going to look at solving a basic series DC circuit. Okay, there's our circuit, and we have three resistors in series representing our load. And if we use electron flow, it would be the current like that, negative to positive. And notice that there is only a single path for which the current to flow. So in a series type circuit, the total current, which is the current leaving or returning to the battery, is equal to the current through load 1 equals the current through load 2 equals the current through load 3. Okay? And Kirchhoff's voltage law says that the sum of the voltage drops across the loads equals the total voltage, in this case 25 volts. Alright, so let's go and solve this and see what we get, okay? Alright, so step 1, we can say that the total resistance, RT, is equal to R1 plus R2 plus R3, and that's simply going to be the sum of the resistances. So we have, mind your units, so I'm going to put everything in k ohms, so 1.5 plus 0.5 plus 0.25, which will be 2.25 k ohms. Alright, step 2, the total current, which is the same as the current through each loads, as we've already seen, equals E divided by RT. So it's going to be 25 divided by 2.25 equals 11.1111 milliamps. And step 3 says that voltage V1 equals I1 times R1, mind your units, equals 5.555 volts. Step 4, V2 equals I2 times R2, so that's going to be 11.1111 times 1.5 equals 16.6666 volts. And now we have V3 equals I3 times R3. So that would be 11.1111 times 0.25 equals 2.7777 7. At this point, I don't care if you leave the 7 as a 7 or round it to an 8. It doesn't make any difference. Okay, volts. Okay, so if we then add all the voltage drops together, so we can say this is Kirchhoff's voltage law. It says that in a series circuit, E is equal to V1 is equal to V2 is equal to V3. I get 24.9994 volts. It means very, very minor rounding. Okay, which is what we started off with here. Alright, so let's just put a line here, and let's look at the power. Okay, so electrical power has the base unit of the watt, and then we can have, milliwatts, microwatts, kilowatts, whatever we need. But in this course, we're mainly going to be using just the base unit watt and then milliwatts. Okay, so there's 3 basic formulas. Basic power formulas. Okay, and they are power equals voltage times current, or power equals current squared times resistance, or power equals voltage squared. Okay, if you have all the unknown quantities, then you can use any formula that you want. But you should get in the habit of using different ones so you're familiar with them, and don't lock yourself into one type. Okay, so let's go ahead and calculate. I'm just going to use the formulas at random. P1, let's do P1 equals voltage V1 times I1. I'll have to go back, sorry, to get the values. So P1 equals voltage V1, so it's 5.5555 times 11.1111 equals 61.77277 milliwatts. And P2, let's do V2 squared divided by R2. Okay, I have to go back, sorry. V2, which is 16.6666 volts squared, divided by R2, 1.5, equals 185.1837 milliwatts. And P3, let's use current I, 3 squared times R3. Okay, back once again. I3 squared is going to be 11.11111 squared times 0.25. Let's make the units work. equals 30.8641 watts. Okay, now power, the total power, so that will be the power from the being supplied from the battery. Simply add up the branch powers, so it's going to be simply P1 plus P2 plus P3 equals, okay, so it's going to be the 61.7277 plus 185.1837 plus 30.8641 equals 277.775 milliwatts. And we could also say, we could take E times IT. So we had a 25 volt battery, so 25 times 11.11111. Okay, and there, there could be a little minor rounding here, but it is the same number. 277.77. That worked out right on 75 milliwatts. So we've calculated the power, total power, two different ways, and the two numbers are the same, so we're okay. And I think this is the last step, that the total current must be equal to the total power divided by the total voltage, and that's just simply rearrangement of the formula, that power equals voltage times current. That's all that is. Okay, so let's clean that up. Okay, so our total power was our 277, and our battery was 25 volts, and we got total current, which is what we calculated earlier, and there could be some minor rounding, but if you use 4 decimal places, the rounding is usually non-existent or very minimal. Okay, so that current calculation there has to come back and match that calculation there. Alright, so I think we have everything, and that's the basic series circuit. Cheers, have a good day.